All right, for number 15, they ask us to evaluate the integration from 3 to 3 of this function. Remember that anytime your upper and lower limits of integration are the same, a and b are equal to each other, your area under the curve is always going to be 0. So our integration was 0 there since they were the same. All right, then for 16, they tell us that the integration from 0 to 2 of this function is 35 over 6, and ask us if they just switch the a and the b values, what would that integration be? So that's another one of our properties, that if you switch a and b, that the answer that you get would just be the opposite of when they're in the reverse order. So whatever the integration is from a to b, then the integration from b to a is just the opposite of that. So since the original one was 35 over 6, then from 2 to 0 would be negative 35 over 6. All right, and then for 17, it says to find the area under the curve from 0 to 3 for the function 2x minus 4 using geometric formulas and using integration. So let's start with using geometric formulas. I'm going to draw it first. So 2x minus 4, I have a y-intercept of negative 4 and a slope of positive 2. So I'm going to start at negative 4, rise 2, run 1, rise 2, run 1, rise 2, run 1. So that gives us our line. So area between that line and the x-axis from 0 to 3, that's our area under the curve. So that's going to be this piece right here and this piece right here. Now remember, if it's below the curve, the area is going to be negative. If it's above, it's going to be positive. So down here, I'm going to do 1/2 base times height. So you can see that our base is 2 and our height is negative 4. So when we do 1/2 times 2 times negative 4, we get negative 4 for this area. And then for this piece over here, our base is 1 and our height is 2. So if we do 1/2 base times height, we're going to get 1 for that area. So the negative 4 plus the positive 1 gives us a total area under the curve, a net area of negative 3. They also ask us to work that using integration. All right, so if I'm going to integrate this, they're checking to make sure I know area under the curve is the same thing as integration. Here's my a value, here's my b value, and here's my function. So that's the definite integral from 0 to 3 of that function. So if we integrate 2x, that's just 2x to the second over 2. And then 4 is going to be 4x, because remember, if it's a constant, you just multiply it by x. So now we're going to clean this up a little bit. Those 2's would drop out, so we would just have x squared minus 4x. That's my antiderivative. I haven't plugged in a and b yet. So let's go ahead and plug in b. So that would be 3 squared minus 4 times 3, so 9 minus 12. Minus, then we'll plug in our a value. So if we plug in 0, we're going to get 0 minus 0. So that is going to give us negative 3. So you can see it doesn't matter if we work it out using geometric formulas or integration, we're going to get the same answer either way.